Okay, so we can start now. So I think almost all people can. So am I audible? Hello. Oh, okay. Okay, thank you. So today, hello, welcome everyone. So today we are in this class where we'll discuss about the analytical chemistry. So the course instructor is Professor Devashish Ray from IIT Kharagpur and myself Shivankar Mondal from Indian Institute of Science, Bangalore. So I am one of TA of this course. So last class we have discussed about the chemical and materials analysis method. So in the first class, basically we have learned what is the importance of analytical chemistry and what are the application of analytical chemistry, and in this concept of analytical chemistry, how we can use this analytical chemistry concept in different field. So that things we have learned. So today we are in second week of this class, and where we'll discuss of the role of analytical chemistry and different technique. So basically here we have seen five class. So in the first class where we have seen the role of analytical chemistry, basically different sample preparation method, and lecture 7 and discuss about the weight assaying method and other things we will discuss little bit. Means I will summarize this class, and then we will discuss some question after summarize the class. Okay, so basically in lecture 6 what we have seen that I think I can take some later point. So basically, in lecture 6, we have learned about the sample preparation, where we have learned that the assay method, which is a most time-consuming state and most error-prone and most laborious process. So here we have learned that suppose we have some O which contains some iron oxide or something is there. So and we want to measure how much iron is there, and so to measure this iron concentration in that sample, so we have to get the form of iron 3 plus, because here the iron is plus 3 oxidation state is present. So we have to get the iron 3 plus form. But in ore here, what is called different with iron oxide, different other materials also there. So we have to separate this iron oxide from the ore sample. So where we have learned that to get a solid sample we can crush and pulverize and then grind, where from after grind we can get the powder sample. Okay, and to powder, from the powder sample we have to make that powder sample homogeneously mixed powder sample, homogeneous sample, so that all the sample or powder sample is fine in structure. So after getting this sample, how we can separate this sample, because in ore sample different type of sample, maybe there can some liquid impurity can stack, or some gas can be congealed or on that ore sample. So if that is there, then how we can separate from each different component from that sample. So there where we have learned that suppose we have some solid or liquid or gas component, then how you can separate from each component from different that ore or fine powder sample. So if you want to separate from solid, so we have learned that density floating method, where basically you can mix different component in flowing some liquid or something, so that if the density of different component is different, then it can float different rate, and the solubility of that solid, if you use some solvent which is some component is soluble and some other solvent component is not soluble, then you can separate one soluble component and one non-soluble insoluble component. And if you want to separate from solid to liquid, then you can heat the sample, and after heating that sample will melt, so that sample can trap on some component, so that you can separate the liquid sample from the solid sample. And if it is consume some gas, then you can heat and you can parch the sample with some inert gas like nitrogen or argon gas, so that whatever component is there, that will come out, and you can trap that gas with some components, some membrane which can specifically trap that particular gas. Okay. And after that we have learned that the liquid separation. Suppose you have some liquid, so filtration method is there. Basically different type of filter paper usually used, that is in school level also we have done that. If you have some liquid sample and you have some precipitation, then you can pour that precipitation on the filter paper, and whatever insoluble product is there, that will stuck on the filter paper. Okay. And if you have the liquid two liquid you want to separate, then there is distillation method is there and decantation method is there. So distillation method, basically you have to heat the sample. Suppose you have some solvent and you want to distill it. Basically, suppose you have some solvent, some DMSO or take DME, some solvent, organic solvent is there, and there is some water vapor or water impurity is there. Then you want to distillate that solvent, then you can heat and above 100 degrees Celsius, then water will vaporize, so you can get the pure solvent. And if you have to remove some gas, so that liquid you can purge with the argon and nitrogen gas. So that suppose you are doing some experiment or some electrochemistry experiment as an example, then suppose in that system the oxygen can affect your affect your experiment, then you can purge nitrogen or oxygen, and oxygen can come out or remove from the solution. Okay. And if it is a gas sample, then gas filtration from the gas sample you can filter a solid sample by filtration method. But in these two filtration method, maybe you have to use different separator or something. And then in liquid sample, filtration process or aerosol process is there. And if you want to separate two gas, then you can do diffusion or differential diffusion process. Basically the principle of glass chromatography, where you can basically some organic group you want to, means organic molecule you want to separate, then you can use gas chromatography. Then you can separate one component and from other component. And if you connect this GC with some mass spectroscopy, then you get to know what is the component from the molecular mass of that component. So from the lecture 6 we have learned all these things. So on that this topic I will give some question. So if people can read okay, I will give 1 minute or something, then you people can read the question, and then you can write the answer in the chat box. Okay, I think that will be good, and it will be more involving to the student. Okay. So so this is the question. I will wait for 1 minute. Then after that, I can discuss this question. So the question is, what are the steps followed in filtering and analyze precipitate? So the first question is decanation, then washing, then transfer the sample. Second question, washing first, then decanation, and then transfer. And third one, C option is decanation, then transfer, then washing. And fourth one is washing, then transfer, then decanation. Okay, Anagya written that C, option C, decanation, and okay, I think Mr. Padal had written A. So the answer is A. So decanation method. Basically, decanation means suppose you have some sample and it is suppose in liquid state and some solid compound is there. So basically, if you filter, basically you have taken some conical flask, okay, and some funnel you have taken, and there some filter paper is there. Okay, so decanation means you have something, so you get decant on the filter paper. Okay, so that means this is the decan. So whatever liquid sample is there, that is coming in the conical flask, and whatever solid sample is there, that is on the filter paper. So if you want to remove some impurity or something which is soluble, some suppose it is insoluble in water, which is there with your solid sample or precipitate sample, then you can wash with that after that. So whatever uh, liquid sample is absorbed on your precipitation, that will wash, and then you can transfer this solid sample to your some vial or something. So if you do some washing first, so first you have to decant this sample, then after that you can wash this. So wash if you do, then you have to what is called, first you have to decant this liquid somewhere, then you can wash this. Okay, that case your precipitated sample can be transferred. Okay, so that time your sample loss will be there. So the answer is A. Okay, next question is how can you make a physical separation of a solid sample from a liquid mixture? Okay, so four option is there. First one is density floating, second one is distillation, fil third one filtration, D is solubility reference. So Anjana had written A, the density floating, then Padel written C, Priya written B. B means distillation. So, how can you make a physical separation of solid sample from the liquid, from a liquid sample? So means you have the liquid sample, and from there you have to solid separate solid sample. So we can go to the previous slide. Here I have mentioned that suppose you have a liquid sample and you want to separate from solid sample. So that is the method is filtration. So floating method basically to separate two solid product. So we have a solid sample and we want to separate solid product. So floating method is the solid to solid separation, and from liquid to solid separation, that is filtration. And what are the other things is distillation. Distillation basically for the liquid separation. Suppose you have liquids, two liquid sample mixture, then you can separate from one liquid sample to another liquid sample. Okay, and then density plotting for solid separation. Solid solid separation. And filtration is the solid liquid or from liquid to solid. Okay, and solubility difference, that is also for solid, from solid sample to liquid solid sample. Okay, so the answer is C. Okay, So from this we will go to the next lecture where basically from the first sample we have learned that how we can we have given some ore sample, and from there you make the powder sample. Then you have that powder sample, and you have learned that how you can separate from powder sample to solid, means that powder sample we can means separate, how you can separate the liquid sample, gas sample if it is absorbed on that powder. Okay, then if suppose you are I think where is cursor? Okay, so that thing is second what is called lecture 7. We have learned that if you have solid sample, liquid sample, and gas sample, then how you will treat further so that you can get some analyte which you want to measure, or you want to know what is the analyte and what are the concentration of that analyte is present. So that solid sample I'll discuss later. So liquid sample is there. Suppose you have the liquid sample and you separate from the compound. Okay, and when you will separate, that time you have large volume of sample molecule. Then you can that separate sample you can evaporate it so that whatever solvent is there, suppose it is water, then water can evaporate, so you get some concentrated sample. So some concentrated sample you can get, then you can easily get to know what in small beaker or small conical flux you can do the experiment. Okay, and suppose you get some solid or of this sample, and it is not insoluble in some organic solvent or something, then what you will do that time? That time we learn that you can do the fusion process. So fusion process basically you have to heat the sample in high temperature so that the sample can melt, and then that sample melting sample you can treat with acid or alkali sample alkali alkali solvent, so that it can reduce or it can destroy the organic part of the sample. So basically when you are doing this acid treatment or alkali treatment, that is known as the wet acing method. As means you are decomposing some organic part or some component which is coordinate with the metal center. Okay, so okay, also you have learned that evaporation method. Basically, you are concentrating your liquid sample. So in liquid sample, you are concentrating, and we learn that bumping process is there, which is more dangerous, because when you are concentrating the sample, the solvent is evaporating, and it can bump on your experiment who is doing the experiment. So we have to be very careful about the bumping. And other things is the acing method, where we have learned that if to decompose the solid sample with we have to treat the component nitric acid or sulfuric acid or peroxide, hydrogen peroxide, or aqueous bromine atom, or different combination of these concentrated sulfuric acid and all these things, so that we can get is S compound, or which is form some CO2 and H2O, and you can get a pure metal component which you are interested. Okay, so in this after on this topic we discuss on two question. So this is the question. I'll give 1 minute so you can write the answer in the chat box. So choose the incorrect option for the following processing of samples. So solid sample is crushed, then pulverized and grind to make a homogeneous, or ideal solvent should be chosen to dissolve the sample including analytes. In case of liquid sample, solvent evaporation does not make any change in the concentration. Option D is insoluble sample requires chemical treatment to convert the analyte into soluble form. Abhashek. So maybe I pronounce a little bit different. Mr. Abhasef has written C, and then Bhi- Bhikethoja, I think he has written B. Okay, B. Raj Patil has written D. Insoluble samples require chemical treatment to convert the analyte into soluble form. Okay. So you have to think it is written that incorrect answer. Which one is the incorrect answer? Okay. So insoluble sample require chemical treatment to convert the analyte into solvent soluble form. Yeah, that is the weight acid form. Okay, so this is the correct statement. So it is the incorrect. So solid sample is crushed, pulverized, and grind to make a homogeneous. So Surya also written C. So answer is C because it is written the incorrect option. So if you evaporate the sample, then what is called it is your solvent volume will decrease. So if concentration is equal to mass by volume, so your volume is decreasing means your concentration will increase. That means your concentration will change. So it is written that solvent evaporation does not make any change in concentration. So if you evaporate, then your concentration will change. So that is the incorrect. So ideal solvent should be chosen to dissolve all the sample including analytes. Yeah, this is also a correct statement. Okay, so I think Abhaset and Surya, uh, they have given the right answer. Okay, so next is what reagent is used for the fusion test of insoluble sample? It is then the manganese oxide, which is known as a pyrolusite. Okay, so the first option is KOH or NOH bead on mica foil, lithium aluminum hydride in mica foil, NH4Cl, NH4OH on mica foil, and nitrous phosphorus pentoxide. Raj Patil have written C, option C. Okay, Abhay has written option A. Then Bhike Tojo. Sorry for because I am not able to pronounce the name, so maybe I am pronouncing in different way. Sorry for that. Okay. Okay, I think whoever answering only that person are answering other people. I don't know how many people is there. So please, all people can answer and try to because these all are very simple question. If you watch the video, then I think you people can able to do means can give the answer. Okay, Somodev Kebora, he has written that C, answer C. Okay, so answer will be A because if you have some what is called insoluble sample, then you have to use some alkali treatment or acid treatment. Okay, so basically manganese oxide, if you do with because this aluminum hydroxide, which is a reducing agent, it is a weak reducing agent, and ammonium chloride and NH4OH, these all are what is called in general it will coordinate with the metal sorry iron hydroxide iron sample. So if you use manganese in acid means alkali, then it will transfer what is called manganese oxide to reduced to KMnO4 and MnO4 means manganese peroxide. Okay, so basically what if you do KOH and manganese oxide, and if you heat, basically this is a waste weight acid method. So KOH and manganese oxide, if you heat in the presence of oxygen, basically if you heat in open atmosphere, then oxygen will be there. So oxygen in the presence of oxygen, what will form? K2MnO4 plus H2. Okay, so this one further reduce with 2MnO4 plus, and after that if you treat with acid treatment, so what will happen? Acid treatment, then it will KMnO4 plus manganese oxide plus sulfate is there, so K2SO4 plus H2. Okay, so if you do the balance of this reaction, then this manganese oxide 2 molar manganese oxide, then 4OH, then it will form 2 molar, and this is 2, and 2 K2MnO4, if you give 3 8 hydrogen peroxide, then it will form 2 KMnO4, then this is 2, and this is also 2. Okay, so this is the reaction. So basically suppose you have some insoluble compound, then you have to first do alkali treatment, and then you have to do the acid treatment, so that it will form some soluble component. KMnO4, it is highly soluble in what is called mm, aqueous solution. Okay, so next 8 and 9 lecture, what we have learned that the different apparatus and weight machines. So basically what are, suppose you want to do some experiment and to know what are the apparatus is required, so that things you have to know. And then suppose you get some sample, then how you can weight, which type of weight balance you should use, so that things you have to know. So and in the weight dashing method, we have learn on sample, that is the nickel nickel 2 plus complex. Suppose you, then you have to make, suppose nickel complex which is insoluble, then you have to make this with the some complexing agent, that is dimethyl glyoxane, and then it will form nickel NiL2 complex. Then whatever you have to treat with acid treatment. So basically weight acid method, whatever. So in this method, whatever organic component is there, that is DMG, so that will destroyed by this organic molecule. And when the reaction is complete, that we get to know that if sulfate sulfur trioxide is white film is forming, then the reaction is complete. if you treat with HCl or nitric acid, then your nitrate ion will be there. So to remove this one, so that you can get a pure nickel 2 plus complex. So to remove this nitrate ion or some nitrogen dioxide is there, then you can treat with the urea. So that this urea, which is can easily transform to nitrogen, so that this is nitrogen is a inert gas, so you can get nickel K2 plus analyte. Then after that you can measure whatever component is there. Then after this, I think we have discussed that to which type of microbalance we should use if you have some analyte, and that analyte weight is some region energy. So we have learned that microbalance, semi-microbalance, and microanalytical balance. So in microbalance, where we have learned that you can measure zero point 0.1 mg to 200 gram, and dimension is 0.1 mg. Then semi-microbalance, where we have learned that it can measure 10 to 30 gram, and D value is plus minus 0.01 mg. And then microanalytical balance, we can measure 1 to 3 gram, and D value is plus minus 0.001 mg. Okay, so then after that we have learned that trier process. Basically in the microbalance, if you put something, then it means if you want to measure some things, then you have to take some container, so you have to keep in that container on the microbalance, then you can make that one as a zero. So that is the trier process. And then you we have learn that nickel DMG complex, how after filtration of the nickel DMG complex, we have to dry the sample, and then we have to measure for 2-3 times. If that is the weight is coming constant, then that that compound, that weight we have to take. Then after that we have learned that primary standard and secondary standard. So I think all people know what is the primary standard and what is the secondary standard. So basically, suppose you are making some solution, and if their concentration is not changed with time, or with some light effect, or some oxygen effect, air effect, then that is called primary standard. So if you are making some solvent, and its concentration, or its concentration is changing with time, or with light effect, then that is called secondary standard. So in that case, whatever concentration solution you make, that solution concentration you have to standardize by the primary standard concentration. Okay, so I think here I want to show some video, so how to make a sample, because in lecture 10 also we have learned that how to make a sample in volumetric fast, or this thing. So I'll show one video. I think that will be easy to understand. Okay, so this is some uh, analytical chemistry practical class only. So I was the TA of this course. So you can see, and this is the potentiometric titration experiment. So here means if you want to do some experiment, then we have to decide which requirement is there, which means apparatus is required. So that things is it is here, it is listed. So first we have to choose which is experiment, which is apparatus is required, and how you can proceed some experiment, so that after that you can start the experiment. Okay, so this is the potentiometric titration experiment. So I think after in this course also we will learn about the potentiometric titration, and that time we can discuss more details. Okay, so here we will measure silver nitrate solution. So before doing so, I have put some butter paper to measure the sample, and this is the tire bottom, so we have to press the tire bottom so that it became zero. Okay, and when you will measure the sample, you have to close the door of the weighing balance so that whatever effect for air or some other vibration cannot disturb your measurement. Okay, and now I think we'll measure 0.42 gram of silver nitrate solution. So now question is, suppose I want to measure 0.42 gram of silver nitrate solution, then which type of means balance we should use. Okay, means we get to know that there is three type of microbalance. One is microbalance, one is semi microbalance, one is microanalytical balance. So which type of microbalance means balance we should use? Okay, you can write in the chat box. Okay, and when we will measure some chemicals, so we should very careful that no chemicals will spill out or outside the weighing balance. So after measuring all the sample, then you can transfer carefully to some volumetric flask. So at what things is we learn in lecture 10 also that what is volumetric flask. So basically, if you want to make some standard solution, then you usually use volumetric flask. So this is the 250 kml volumetric flask. Okay. So Abhasa, he has written that microanalytical. Okay. So I have used some funnel, and you carefully transfer the sample silver nitrate. Then you add distilled water very carefully so that any sample cannot go outside. And whatever sample is stick on the funnel, you rinse with the distilled water. Then you add small amount of water and make it soluble first. Okay, so you have to shake properly so that all the silver nitrate whatever it is there, it can soluble. So Jyotiva, she has written that microanalytical balance. Okay. Okay, so after dissolving all the analyte, you can means add the solution. So to make the volume makeup. So therefore means 250 ml of volumetric flux, there should be some line so that it can make volume. So this line you can see, so this line is for the volume makeup. So if you are making the standard solution, then you have to make volume makeup up to this. Okay, and in this case you have to very careful that it cannot go, or if you should not add much solution above this one. Okay, but here you can see that I have added little bit more solution, and its mark this mark is above this whatever mark is there in the volumetric class. But in this case it is okay because silver nitrate is a secondary standard. So you have to standardize the silver nitrate in later by some standard solution. Okay, so for this it is okay, but if you are making some primary standard solution, then you have to very careful that it should not go out of that mark. And this is the pipette. I think this is the 10 ml pipette. So to measure the solution, you have to take some pipette, and I think this is the burette. I think if you do some titration or potentiometric or redox titration, then you have to use this apparatus, and this is the conical flask. Okay, so I think I should stop here. So if when we'll know more details about this potential metric titration, that time we can I can share this video. Okay, so that question I should ask now. So which 0.42 gram of sample measure which type of balance we should use. So micro analytical balance if people have written, but if you see, so if you see here the microanalytical balance, the range is 1 to 3 gram. So we want to measure 4.02 kilogram of sample. So the answer will be microbalance. Okay. So next question is, a sample was weighted 2.156 grams. So which instrument was used for weighting? So if people can answer this question. So I'll wait for 1 minute. Jyotiba has written answer B, and someone written micro analytical balance. So let's wait for 30 minutes again. Sajal has written, so most of the people are telling that microbalance, and it is right. It is microbalance, because microbalance you can measure from K1 to K3 gram. Okay. Okay, next question is, in weight acing process of nickel DMG to complex, is treated with a mixture of HNO3 and H2SO4 acid for destruction of nickel sulfate, to destroy the organic ligand, for the decomposition of sulfuric acid, for both A and B. To destroy the organic ligand, Sajal hesitant C, answers for the decomposition of sulfuric acid. Okay. Raj Patil for both A and B. Okay. Okay, so destruction of organic matter. Yeah, you are Abhishek has written. You are right. So yeah. So weight acing meter, basically you are treating alkali or sulfuric acid or nitric acid treatment to destruct this organic part to form CO2 and O2, H2O conversion. So these things answer is B. So to destroy the organic ligand only. So that is the method of weight acing method, where you are on to destroy the organic part so that you can get the nickel complex. Okay. So next one is, from acidic solution, urea can effectively be used for the removal of what? So Sweta has written A, Surya also has written A. Yeah, A is the right answer. Okay, to remove okay, NO2 and a nitrate, because these are oxidizing agent. And this urea basically easily can transform to ammonia. Okay, ammonia, and it is very important in agriculture field and polymer industry also, this urea. So basically to remove the NO2, and if you are treating in acid, wet acid process some HNO3 acid, then what is called your residue will be their anion component HNO3 NO3 minus, so it can coordinate with your nickel 2 plus or something. Then to remove this one, usually use ammonia treatment, so that it can easily remove nitrate. Okay, so in lecture 9 and 10 we have learn about the filtration ignition method and different crucible filter paper and their uses. So basically different type of simple crucible and different type of crucible we have learned that porcelain crucible or aluminum crucible or silica crucible and platinum crucible. So basically different for different temperature range, if you want to do some what is it, fusion or ignition method, then you have to use different crucible. So it's depend on the temperature, what temperature you want to do the experiment, that on that basis we have to choose the crucible. Okay, and then at last we have learn how, suppose we have some ore, and initially also we have discuss about the iron complex, iron ore, and then in that sample we have iron 3 plus. Then how we will soluble in the solution, then how we can separate particularly this iron sample from the solution. So basically you have to add or dropwise you have to add ammonium hydroxide solution or ammonium chloride and ammonium hydroxide. So then it will form ammonium sorry, iron trihydroxide will form, which is a brown color precipitate. And we have learned also that this form cannot be exist. So with this it is three water molecule is coordinate, and a hexa complex will form. Okay, so here we also have learned that when we will transfer the sample, we should very careful that no sample can destroy it or discard it from the beaker. Then we will get some error result. So we have to flash the hydroxide on the beaker, and it will, that precipitate will form ammonium iron hydroxide precipitate, brown precipitate will be there in the filter paper. Then we have to, you have to transfer to some crucible, then you have to heat for some temperature, because in filter paper basically it will form carbon. So carbon we have to, means filter paper we have to destroy. So then you will get the iron complex of iron complex iron 3 plus, because if you heat for high temperature, then whatever water molecule will there, that will be evaporated. Okay, then you will get the iron complex, and that sample you can do the redox titration. So whatever you can take the burette and pipette. So I think you will learn more details about the redox titration process. So from there, how much iron 3 plus is there in the sample, that things you can calculate, so that we can get to know that how much iron complex is there in the ore sample. Okay, so from up to lecture 10 we have learned up to this, that suppose we have some sample, then you want to do some experiment to know how much iron complex or some metal complex metal is there, then how you can process and how we have to sample prepare the sample, that things we have learned today. So On that basis, we'll discuss on two question on this lecture 9 and 10. So the question is, what reagent is used in qualitative analysis of iron 3 plus solution for the precipitation of iron hydroxide? Surya has written answered V. Sweta also written V. Sajal Sajju B. Yeah, I think B. Yeah, B is the right answer. So basically, in this solution, dilute ammonium chloride. Chloride means ammonium chloride is present in ammonium hydroxide solution. So this ammonium hydroxide we have to place on the iron complex, so it can transfer iron OHL whole 3. Okay, and along with this water molecule will coordinate, so hexa complex will form. Okay, so this is B the answer. So it is there what which crucible has the ability to ignite at temperature of 1400 degrees Celsius. Okay, so there is four type of crucible: porcelain crucible, glass crucible, Gauge crucible, and aluminum oxide crucible. So Abhasep has written D, Jen Jyotiva has written A, Raj Patil has written C, Surya D, Sajal A. Okay. So means as I already mentioned, that means if you want to do what temperature you want to do the experiment, so on that basis you have to choose which type of porcelain means crucible you have to use. So if you want to use porcelain crucible, so that porcelain crucible temperature I think 11, yeah. So this maximum you can go 1100 degrees Celsius. Okay, and glass crucible 200 to 500 degrees Celsius you can do the measurement. Okay, and gauge crucible above 500 degrees Celsius you can do, and aluminum oxide crucible that is you can go up to 150 degrees Celsius. Okay, so that if you want to do 150 400 1400 degrees Celsius temperature some reaction, then you have to choose aluminum oxide crucible. Okay, so the answer is D. Okay, so this question is from the last week question, last week class question. So fill in the blank with the suitable option given below. So in the DR kidney sample after the dry acing process, arsenic present in the sample was primarily converted to what? A. Surya also written A. Raj also written A. Saita written A. Anjana also written A. Yeah, answer is A. So basically, when you will heat the arsenic pentox arsenic compound, so that oxygen is there, so it can convert easily to arsenic pentoxide. I think up to this time also over. So I think up to this is the thing. So I think next class okay, we'll learn about the what is there. So chemical equilibrium and basics of chemical analysis. So that things okay, we'll okay, learn. Okay, so if any person have any question, then okay, you can ask. Yes. So above 500 degrees Celsius, yeah, above 500 degrees Celsius, that not means that you can use for high temperature. It maybe you can go up to 600 degrees Celsius or something. Okay, I think I should mention this. Okay, so some other person have any question? Okay, then I think no one have any question. Then I can call off the meeting. So thank you everyone for joining the session. So shall we call off the meeting? Okay, thank you. Thank you.